variation of parameters. We want to use that technique to solve this problem. X bar prime is equal to the matrix 2, 1, 3, negative 2 times x bar plus the vector or the matrix 0, 4. Now this problem is a little bit different than the previous ones because we have this plus 0, 4. So what we're going to do is, the technique is to solve that first. So we need to find the characteristic equations, the roots, which are the eigenvalues, and then the eigenvectors. And then we'll deal with this. So first we're going to solve just this equation. So we need to compute the determinant A minus lambda I, where this matrix is the A. So here's the A, and if you take away lambda I, that just means you take away lambda from their diagonal entries. And we want this determinant to equal 0. Now I hate when I have negative lambdas. So I'm going to get a quadratic equation, and I'd rather it be like lambda minus 4 times lambda plus 5 as opposed to 4 minus lambda times 3 minus lambda. Well, I need to compute the product of those two, but I can negate both of them. So I get lambda take away 2 times, you negate that, you get 2 plus lambda, or lambda plus 2, minus that product. But that product is negative 3, so it becomes plus 3. So this here is lambda squared minus 4, but then you add 3. You have lambda squared minus 1. So this must be 1, because only 1 minus 1 will give me 0. So if lambda is 1, if lambda squared is 1, then lambda is plus or minus 1. Okay. So let's deal with the first lambda, which I'll call lambda 1, which is 1. Now we want to solve this matrix augmented with 0, except lambda is 1. So 2 minus 1, negative 1, 3. Negative 2 minus 1 is negative 3. Well, if you divide the second row by 3, get the number smaller, you say, oh, it's the same as the first row. So when you subtract row 2 minus row 1, you get a row of zeros. So the only significant equation is the top one, top row. It says that K1 or 1K1 minus 1K2 is 0. That is, K1 is equal to K2. Let them both equal 1. So big K, vector K1, is little k1, little k2. So that tells me that the vector x1 is 1, 1. It's k times e to the lambda t. E to the 1t or e to the t. So let me put this, now I guess we have one still. Now let's work with lambda 2, which is negative 1. So let me just rewrite that matrix. I wrote on it a bit. 2 minus lambda, 3, negative 1, negative 2 minus lambda. Now I let lambda be negative 1. 2 take away a negative 1 is 3. Negative 1 and then 3. Negative 2 take away a negative 1. That's negative 2 plus 1 or negative 1. We'll augment that with the 0 matrix. And since the first two rows are identical, when I subtract it, I'll get 0 for the second row. So that top equation tells me 3 times k1 minus 1 times k2 is 0. That means those two are equal to one another. K sub 2 is equal to 3k1. Well, how about I let k1 equal 1? Well, then k2 will be 3 times 1. So vector k2 is little k1, little k2, 1, 3. And then the vector x2 is 1, 3 times e to the negative 1t, or e to the negative t. Let me erase most of this. So what we have is x1 bar is 1, 1 e to the t, which is e to the t, e to the t. And x2 bar is 1, 3 times e to the negative t, which is e to the negative t, 3e to the negative t. Now, we define a new matrix called phi of t. And phi of t is really easy. It's just, the first column is just x1. It's just those two entries. And the second column is just the entries in x2. Now to review something. If matrix A is little a, little b, little c, little d, and it has an inverse, then the inverse will be the two-step process. You interchange those two entries, and you keep the other two where they are, except you change their signs. And that's step 1. And then you multiply by the determinant. Sorry, 1 over the determinant. The determinant is a times b minus b times c. Okay. So my goal is to find the determinant of, to find the inverse of t. So first I'm going to find the determinant. In fact, maybe I should write this as just 1 over the determinant of a. So the determinant of phi, you multiply those two, you just get 3. Because e to the t times e to the negative t is e to the 0, which is 1. 3 times 1. Minus that product is e to the 0. So the determinant is 2. So the inverse is 1 over the determinant, which is 2, and then you play the games with the entries. You switch these two entries. The e to the t goes there, and the 3e to the negative t goes there. And these two entries, they stay just where they are, except their sign changes. E to the t becomes negative e to the t. E to the negative t becomes negative. That's the inverse. Now, for the long one, the answer is going to be, well, x bar particular, it's going to be phi of t times the integral of phi inverse of t times what's called f of t dt. And f of t big is that. is plus 0.4 or 0.4. So what we want to calculate is this integral. Phi of t is e to the t, e to the negative t, e to the t, 3e to the negative t. What did I get that from? Well, since I wanted phi of t, I look somewhere where it says phi of t equals. It equals that times the integral of phi inverse, which is this part, 1/2 times this matrix times f of t, which is 0.4 times dt. And we want to work out this integral. First thing I'll say is this half can come way out in front. So I have 1/2 times the matrix that's already in front of the integral. This is the matrix in front of the integral times the integral of this times that. Well, let's multiply this by that. You get negative 4 e to the negative t, and then you get 4 e to the t dt. Now don't worry that you're integrating a matrix. This is just basically, it's a matrix. It's the integral of negative 4 e to the negative t dt. I got that from here, dt. And in the bottom is the integral of 4 e to the t dt. That is, it's two integrals in one. So we still have what's in front, 1/2 e to the t, e to the negative t, e to the t, and 3 e to the negative t times the integral. Well, this integral is just 4 e to the negative t. Oops. So since I'm taking the integral, I don't need an integral sign anymore. And in the bottom, you get 4 e to the t. So we're going to multiply the two matrices. Let's not lose the half that's in front. When you multiply this row by that column, you get 4, just 4, plus 4. You get 4 plus 4. And in the bottom, you get 4 plus 3. Now, somehow when I work this out, I got 4, 8. Actually, both of those answers are wrong. You get 4 plus 12. Because this times that is 12. This times what's up here is 4 plus 12. So you get half of 8/16, which is 4/8. So you get 4/8. Okay, now that's a big part of this. And remember, that's what XP equals. That's what xp equals, x particular. So now, after doing all that, we're ready to write down the final answer. Big X is equal to C1 times X1, 1 e to the t. If you preferred, you could have written down e to the t, plus C2 times X2, 1/3 e to the negative t, plus xp, which is 4/8. And that's your answer. It's a long formula, but you have to use it. Let's try one more of these. Suppose that x prime is equal to this matrix times some x vector plus 2 e to the negative 3t. So the job is to find the x. Which vector x works? Like before, we solved this one. So we know that we want the determinant of A, where this matrix is A, minus lambda I is 0. So you have, here's the A, and we take away lambda. So with that product, negative lambda times 3 minus lambda. Well, if I change their signs on both of them, that's okay. Plus, you have once again, as we did last time, if you have this, it surely equals to 1 times that. And you don't have to write 1 like that all the time. In this case, I want to write 1 as negative 1 times negative 1. That's 1. Now, when you are multiplying 4 values, it's the order you multiply is up to you. If somebody asks you to do this multiplication, this is not a calculator problem. It takes much longer to go and find the calculator and turn it on than it is to say 100 times 21 is 2100. You can multiply in any order you want. Well, I want to multiply those two, which gives me lambda. Like I multiply those two and it gave me 100 times 21. And then I want to multiply that result, like the 100, by that product, which is lambda minus 3. Now, if you're multiplying 3 things, you can multiply all 3 by negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. It's not 1. Okay, minus that product, which is negative 2. So you get lambda squared minus 3 lambda plus 2. Lambda minus 2 times lambda minus 1. So lambda is 2 and lambda is 1. Lambda 1, lambda 2. So we have lambda 1 is 1 and lambda 2 happens to be 2. Now basically we want to plug in 1 for lambda. So we have negative 1, we have 2, we have negative 1, and 3 minus 1 is 2. We augment that with 0. The second row is the same as the first row, so if you subtract, you get zeros. I'm going to multiply everything in row 1 by negative 1. Why? Because I want to get 1k1 minus 2k2s is 0. That means k1 equals 2k2s. And if I let k2 equal 1, then k1 is equal to 2 times 1, 2. So vector k, k1, is equal to little k1, which is 2, little k2 is 1. It's 2, 1. So x1 is going to be 2, 1 e to the lambda, which is 1, t. 1t is just t. I'm going to leave it like that. Now, we do the same thing all over, but we plug in 2. 0 minus 2 is negative 2. That is 2. That is negative 1. 3 minus 2 is 1. If I divide the top row by negative 1, get 1, negative 2, 1, negative 1, 0. And if I add, to replace the second row, if I add these two rows, you add those, you get 0, you add those, you get 0, you add those, you get 0. So the top equation tells me k1 minus k2 is 0. That is, k1 equals k2. Well, let them both equal 1. So k2, the vector, is equal to little k1, little k2. That means vector x2 is 1, 1 times e to the lambda, which is 2, t. So back to x1 for a moment. It's the same as 2e to the t, 1e to the t. x2, e2 to the t, e2 to the t. So let me write this up on top, and then we go from there. x1 is 2, 1, e to the t. And x2 is equal to 1, 1, e to the 2t. E to the 2t, e to the 2t, 2e to the t, 1e to the t. So we solved what we can call the homogeneous system. We solved this. Now we need to solve the whole thing. And a particular solution is, well, before we do that, why don't we just define the phi of t and the inverse. Phi of t is, well, the first column is just x1. It's just x1. And the second column is x2. Now, I want to find the inverse of this 2 by 2 matrix. So having the determinant would be a good start. You multiply those two, you get 2e to the 3t. Minus, you multiply those two, you get e to the 3t. So the difference is just 1 e to the 3t. So now we're in a better position to write down the inverse. First, it's 1 over the determinant, which is 1 over e to the 3t, times the matrix. You interchange the entries on the main diagonal, and on the non-main diagonal, you keep them where they are, but you change the sign. And there's your inverse. But let's actually do this. What is this times that entry? The answer is it's e to the negative t. because 1 times e to the 2t over e to the 3t, since the bases are the same, you subtract the powers. 2t minus 3t is negative t. And when you do that one, it's just going to be negative e to the negative t. And when you take that entry, let's even keep the negative. 1 times negative e to the t over e to the 3t. The negative is not going to change. The base is the same. You have 1t. You take away 3t. That's negative 2t. Negative e to the negative 2t. That 2 is going to stay. 2t minus 3t. Well, we did that up here. It's 2e to the negative t. That is the inverse. Now we're going to use that formula that I started to write a moment ago. You have that x particular is equal to phi of t times the integral of the inverse of t times f of t opposed to f of x dt, where this is f of t. So what we have is x of p is phi of t, which is right here, 2 e to the t e to the 2t e to the t, just copying it down. And then an integral sign, and then phi inverse of t, which is right here, times f of t, which is that, times dt. Okay, let me erase this so I could continue. So xp is equal to that first matrix times the integral of this times that dt. Well, let me do this times that. It's going to be 2 e to the negative t plus this times that, which will be negative e to the negative 4t. And now I do the second row by the first column. Get negative 2e to the negative 2t plus 2e to the negative 4t dt. So I want to integrate the top. I want to integrate the top. And then I integrate the bottom. And I put the integral of the top in the top and integral of the bottom in the bottom. So I have xp is still equal to this matrix in front. I'm not going to multiply it by anything until I find that integral. The integral of 2e to the negative t is negative 2e to the negative t. The integral of that will be plus e to the negative 4t over 4. Now I take the integral of the bottom, which is just e to the negative 2t minus a half. 2 over negative 4 is negative a half. E to the negative 4t. So I have that for xp. Okay. So now we're going to multiply these two matrices. Now remember, this is just one term. This is one term. So I multiply this row with that column. And I get that xp is -4 minus 1/2 e to the -2t. Second row with the first column is -2. Oops, that's wrong on top. I have to multiply this by all of that. It's -4 plus 1/2 e to the -3t. That's this times that times that. Now I'm going to do this times that. Plus 1 minus 1/2 e to the -2t. Okay. Now I'm going to multiply e to the t by the top entry. And I get -2 plus e to the -3t over 4 plus this times that, plus 1 minus 1/2 e to the -2t. Combining a little bit, so that's xp. Combining, like -4 plus 1 is -3, so that's -3, plus 1/2 e to the -3t, minus 1/2 e to the -2t. -2 plus 1 is -1, plus that, e to the -3t over 4, minus 1/2 e to the -2t. Now that's xp. And remember, x general, the general solution is always the homogeneous solution plus the particular solution. So the general solution, call it xg, is equal to c1 times x1. This is part of the homogeneous plus c2 x2. Okay, that is the homogeneous plus this goes here. And there is your answer. There is the general solution. That completes the section on variation of parameters.